let's get started. An introduction to Linux. Let's first talk about what Linux is. To talk about Linux, we have to talk about these two gentlemen, Ken Thompson, Dennis Ritchie. They worked at Bell Labs. This picture was taken at Bell Labs, and that is I believe that's a PDP 11 that they're working on. It might be a PDP 7. I don't know them well enough to tell the two apart. Is that a 7? That's a PDP 7. That was the machine on which they wrote Unix. Unix came from Bell Labs pulling out of a broader project called Multics. Right? I'm teaching this history because it's somewhat important. This was in the early 60s. Now, I want you to imagine what computing was like in the early 60s. Right? There were reals and relays, and the computing power there, you know, they named it and they measured things in K words, right? Not in megabytes and gigabytes and terabytes, right? In thousands of words. So it's a very, I don't want to say restrictive system, but it wasn't, they didn't have nearly the resources that, you know, a wristwatch has nowadays, which is something pretty fantastical. They wrote an operating system, and as part of writing that operating system, they wrote a language with which to write operating systems. So we get both C, the programming language, and Unix out of Bell Labs. They kind of go hand in hand. Now, what they did is they built this really cool, really awesome operating system with a bunch of really awesome features. And Unix itself wasn't open source as we know it today, but they did have source code licensing. Universities, for example, would take this C code and they would start fiddling with it and teaching operating systems and teaching computing with it. University of Helsinki in Finland was one such organization, and a hacker there by the name of Linus Torvalds said, hey, this Unix paradigm's pretty slick. I want to make my own. So he started coding from scratch. Is there music playing?
Yes. It's coming through the...
I wonder if that's coming from my projector. Or from my... That is likely coming from my Pandora station here. So let's... Hey. Yeah, so about that. Crazy.
Okay.
All right. Much better. Sorry about that. What's going on with that? So open source. So the University of Helsinki in Finland gets a copy of Unix. A hacker named Linus Torvalds says, hey, this is pretty cool. I want to make my own. He releases it, calls it Linux. That was in 1994. 1991. By 1994, the Linux and Unix and BSD ecosystem is actually starting to flourish because it's pretty useful, right? And we get another hacker, name of Richard Stallman, who wants to install a printer driver, but he can't. It's a proprietary printer driver, and he goes, well, this is stupid. Why should someone be able to have, you know, a piece of hardware that they can't use? So he started this philosophy called open source, right? Which is that you use copyright and the ability for a copyright owner to license their copyrightable material in a way such that it's shareable. And he started this GNU project and the GPL, the GNU Public License, which basically says, you can use this thing that I'm giving you for free. However, if you modify it and then redistribute it, you have to give it away for free as well. Also known as copyleft. Linux was released under this license. So let's talk a little bit about the architecture and design of Unix and therefore by association Linux. There's a couple of really cool principles that it starts with. Number one is that it's a multi-user, multi-tenant operating system. In the 60s, this was awesome. Nowadays, it's just kind of taken as, that's the de facto. What is a multi-user machine? A multi-user operating system is that Joe can log in and Sally can log in and they can do things. A multi-tenant operating system is that Joe and Sally can be logged in doing things at the same time. Right? One of the core fundamentals of computing in general, and this goes all the way back to Alan Turing, the father of computing, make a program that's small and simple, and make all of your programs small and simple, and then join them together to get the complexity, right? You don't need to write Facebook as a single monolithic application, right? Facebook has a whole bunch of services that they run, and that runs your website, the website, right? A whole bunch of stuff runs Facebook. Another philosophy is be very liberal in what you accept as input, but be very, very conservative as to the type of output that you generate. Combine that with number one, simple programs, and you get the basis for using programs to do steps along the way, combining them together. What's known as pipelining. Take one command, do something to a bunch of data, hand it off to the next command, do some more stuff with that data, and so on and so forth. Another thing that's pretty cool is everything is a file. Your hard drive is a file. The partitions they're on are a file. The mouse is a file. The terminal is a file. The serial console is a file. The network card is a file. That seems kind of silly. Well, it's really useful when you get into the idea of everything being a file and you've got pipelinable programs, then you can actually start doing fun stuff with your actual hardware. Configuration is stored in ASCII. Now this was mind-blowing. 1960s, right? If I do my value equals true, that's my val equals a couple of spaces, TRUE. There's 15 bytes of data right there if you use ASCII, give or take, right? To store a binary value, right? This was, you don't do that. You've got to save every bit, So storing stuff in ASCII was kind of revolutionary. Disk space, they saw, was going to become cheap. It wasn't then, but it was going to become cheap. Therefore, they made the design decision that configuration should be stored as text so that the person who's knowing it can just say foo equals true instead of bit number 17 needs to be a 1. Right? And then a single-rooted hierarchical file system. This is a little bit of a mouthful, but it basically means that everything starts from a single point as far as the file system is designed. Windows is the opposite. It's a multi-rooted file system. If you put a CD in, you get a C drive, a D drive, right? You mount a network share and it's an F drive. Your hard drive is the C drive, right? That's multi-rooted. Everything starts from a different root. On Linux and Unix, it's a single root. So you take the file system from disparate places and you mount it all into a single namespace. Pretty useful little tool or feature. All right, so multi-user versus multi-tenant. It's kind of the difference between a house and an apartment building, right? You've got multiple people logged in doing things at the same time. This means that you have to have good walls, right? Good segmentation. If I own a house, there's nothing other than common sense keeping me from ripping the entire facade off, right? And the only person that it affects is me. But if I go in and tear down the entire facade off of the apartment complex, every other tenant is going to be inconvenienced and shivering come winter, right? So there's a lot of stuff that happens inside Linux that is all about keeping users from doing things they're not supposed to. And just like there's a superintendent of an apartment complex, there's an all-powerful user known as the root user, ROOT, that has the keys to the kingdom, if you will. And just like we learned from Spider-Man, with great power comes great responsibility, right? So make sure that if you're using root, which you should probably not be except for very rare cases, you need to be careful, right? Because you can tear the entire building to the foundation if you're not careful. Another thing that we find in Linux is that things are aligned a little bit in layers. At the very lowest layer, we have the hardware, which is electronic pulses moving across copper wires or gold wires or moving across some sort of medium. We move up a layer or two and we end up in the kernel. So you're going to hear about the kernel. The kernel is what does all of the processing, right? It says user A can do this but can't do that. User A is running a big mathematical construct in this supercomputer. User B is editing a blog post. User C is writing a Perl script, right? To interface the kernel with the hardware, you're going to find modules more often than not. You can build into the kernel direct access to the hardware, but what's most often done, however, is you build a module that you can load into the kernel that interfaces with the hardware. So if you've got a new network card or a new video card and you want that video card to work, you need to make sure that you've got the appropriate module. Now, today, in 2016, it's not nearly as painful as it was. Linux is now mainstream, so people who release hardware, they're not going to look at you sideways when you say, hey, where's the Linux driver? Right? You're going to still find problems. A friend of mine who works for Red Hat, she just got a brand new laptop. It's a Lenovo Yoga. And there's not a driver for the BIOS yet. So she's not able to install Linux on her brand new laptop. This is really becoming more and more rare, though. It used to be that you had to go through and actually add code to the kernel or add code to a kernel module to get certain esoteric hardwares to work. But that's not the case anymore. Most often there's a generic interface. Here's a good example of this is video cards. There's a generic video card interface that all the video cards support. And so you can get basic video to work. But if you want to do like hardware acceleration and play games, etc., do AutoCAD or whatnot, you have to get the video cards manufacturer's kernel module installed. It's not all that difficult, but check the documentation for said piece of hardware. Coming up a layer above the kernel, there's a layer called userland, or user space, depending on who you ask. This is where all the other programs run. Now, the programs can be anything as simple as a text editor or as complex as a web server. There's a special classification of userland programs called shells. And this is your interface. Familiar with the DOS prompt? That's a shell, right? The shell you're likely to use is bash or Bourne shell or a derivative thereof. Those are usually the defaults. There are others that you can use. K shell for you old IBM folks. You can use Ubuntu, I believe, has a very simplified bash-ish clone called Dash, D-A-S-H, that for 95% of the people using it, they're not going to be able to tell the difference. But you're going to be using a shell that interacts and lets you launch other programs. Or you're going to be using a graphical shell, which is what you're usually familiar with a Windows machine. Okay? Are there any questions up to this point? Questions or comments? All right. This is an example of the file system hierarchy. Right? This is a singly rooted file system. The root, aka slash, is the very top of the file system. And then there's a bunch of folders. These aren't all of the ones that exist. But you're going to find slash USR, slash home, slash var, and there's something called the File System Hierarchy Standard, which is a standard for what things go in what places. And for the most part, things fall in those places. But you're going to find, like all standards, the lovely thing about them is that there's so many to choose from, right? And whenever you find yourself with too many standards to choose from, what's the next step? You make a new standard, right? So that your standard is the one that's right. But for the most part, you're going to find things in slash bin and slash user slash bin that are the programs that you run. Right? There's some distinctions, and you're not need to worry about those right away. sbin and slash user slash sbin are the programs that the super user should run. Right? You're going to find your configuration in the, oh my gosh, I erased it. There was an etc directory in there. That's where configurations are supposed to go. var is for variable data. Log files, mail spools. There's a whole bunch of, you don't need to worry too much about this right now as a beginning level. But just know that there are certain places where things should go of certain types. Right? Configuration for your servers goes in etc. The actual daemon goes in bin or sbin, etc., etc. And there's a couple of special ones. Slash sys. Write it down here. Slash proc. Those are special file systems. Like I said, everything is a file. So slash sys gives us an interface to all of the hardware via files. Slash sys slash fs slash blah 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 is a pointer to the file systems that we use. Slash proc is for the internals of the kernel. So it doesn't actually exist on disk anywhere. It's an interface to fiddle with or look at what the kernel's doing. Underneath slash proc, you can see every one of the processes that are running, which is kind of cool. Your home directory usually ends up under slash home. Libraries are for things that you want to share. Like, I wrote a really cool application for calculating pi. Right? And instead of everyone else having to write that same application for calculating pi, I turn it into a library, and someone else can say, hey, I need to calculate pi, so I'm going to include Derek's pi calculator. And then I can just say, include Derek's pi calculator, and my application now knows how to calculate pi. Stuff like that goes into lib. Right? We talked about this a little bit, putting the config in ASCII. You don't want, this is fantastic. The biggest reason is that all you need to configure your system is a text editor. Right? If you know how to run a text editor, you know how to run the configuration. And a cooler thing is that most config files actually have what's known as a comment, or a comment character. Right? So you can put into your config file the line above it, this next line controls such and such. And use this value for this and the other value for that. So you can store the documentation hand in hand with the configuration, which is pretty slick. Right. When you get talking about Linux, you're going to hear distributions. And you're going to end up in distribution flame wars, I guess is not, I don't know if that's the right way of saying it. Distributions are like pants, right? Everybody likes a different style of pants. Some people like Wranglers, some people like Levi's, right? There's nothing wrong with either one, but some things just fit different people differently. right? So when you talk about distributions, you're going to be talking about Linux Mint. You're going to be talking about Slackware. You're going to be talking about Red Hat. You're going to be talking about CentOS. You're going to be talking about Fedora, Gentoo, Debian, Ubuntu. Really, the big three you're going to find are Ubuntu, Fedora / Red Hat / CentOS. So they're all kind of the same family. And Debian, right? There's a whole bunch. There's thousands upon thousands of different Linux distros for different niches, right? Some people like the word, kilts, and I don't know. Maybe they're the Gentoo guys. I don't know. But pick a distribution, use it. If you don't like it, pick another one, right? Until you find the one that fits. How to install Linux kind of depends on the distribution you're using, right? I am most familiar with the Fedora and Red Hat family. It's kind of what I've done for forever. But other people find Debian or Ubuntu are really useful. If you really want to get really close and have awesome performance, you go with something like Gentoo, where you actually have to do like compiling on the box, so you get the best possible performance. Which is kind of cool. What is a distribution? Linux, by itself, is just the kernel. So if you were to download and install Linux, you would get something that looks like this, right? You're going to get a frame, and you're going to get the engine, or actually you're just going to get the engine in the box, right? And then you have to go out and buy all the other parts so that you actually get a comfortable ride. A distribution puts them together and basically gives you a car lot, right? Of here's all the pieces put together, choose the one that fits you the best, and drive it off the lot, right? If you feel so inclined, there is a great project called Linux from Scratch. If you find yourself wanting to know how hard it is to build a Linux distribution, try doing Linux from scratch. You have to build your hammer before you start building. The first thing you do for Linux from scratch is build your compiler, which is kind of oxymoronic, right? Like, how do I compile a compiler? Well, you've got to have a compiler. So, if you feel so inclined, it's a wonderful learning opportunity. It's called Linux from Scratch. Really quite useful. This is great and all, Derek, but how do I actually use this silly thing, right? You're going to download and install Linux. Maybe not even install it. There's a couple of what are called live distros. So you boot off of a CD, DVD, or USB thumb drive, and and it boots into memory and doesn't touch your hard drive. Right? So if you've got, here's a really good example. When I was learning Linux, I installed it on a separate partition on my hard drive, or so I thought. What I did is I erased all the Windows partition and my mom's publishing company. And yeah, it was bad. So that's not going to happen much anymore. You boot a live distro, you put the thumb drive in, you put the DVD in, you put the CD-ROM in, you boot off of that, and you've got a running Linux environment from memory.
You didn't happen to bring any, did you?
I didn't. But they're really easy to find. You Google live distro, and you'll find them. You put them on a USB thumb drive, and you're good to go. I don't like bringing things like that because you can't really know, unless you do it yourself, that you're getting what you are told. Does that make sense? It's an avenue of attack. And so I don't like being the one handing out thumb drives.
It's expensive.
It's expensive, one, but it's also, go to Google, live distro, follow the instructions on how to install it. It's really quite simple. It's gotten really quite simple lately. Right? when you get into your live distro, you're going to log in, and you're going to see a desktop that you're somewhat familiar with. I'm sure everyone here knows how to run a mouse, right? You're going to see an icon that looks somewhat like this. Right? So you can do all the things that you're used to in a graphical environment and never have to touch the terminal. This is what's called the terminal. So you can go to Firefox and browse the web. You can go to Thunderbird and get your email. You can edit pictures with GIMP, G-I-M-P, right? You can compose music. You can edit video. You can do all those things in the graphical environment that you're used to doing. But if you're wanting to get into the nitty-gritty of Linux, you're going to find yourself getting to the terminal occasionally. Right? So let's cover what the terminal looks like and how we actually interact with it, and then we'll do some examples. The first thing is you're going to open up the terminal, and you're going to get something that looks like text. It's either going to be white on black or black on white, or whatever you want to configure it to. I've got one that's like phosphor green on dark phosphor green, and it's actually got the CRT lines in it. It's kind of fun. But you're going to run commands, right? So from the terminal, you're put into a shell. When you fire the terminal up, you're put into a shell, and then from the shell, you're going to run commands. And the syntax to do that is pretty simple. You run the command name, and then you can pass some switches. Here's a switch without an argument. This is also called an option. So you'll hear that term interchanged, switch or option. They're usually preceded by a dash or a double dash. So you're going to find switches. This is an argument. This is a switch with an argument. So this would be the T switch with the CH argument. Right? So we've got the S switch, the W switch, the I switch, the T switch with this argument. We put two dashes in front of a long argument. So this is the this is the option, not argument, option. And then two dashes by itself, that's optional. But basically it just tells the command, I'm done passing you options or switches, and I'm going to start passing you arguments. There's a distinction there. Switches change what happens. Arguments are usually on what it happens, or what it happens to. So if we made a command that reversed or capitalized every other letter, we would do, a switch for at which letter do we start, and then the argument would be the file from which we gather the text to capitalize every other letter. Right? Here's a really good example. Find is a command that will search from the directory I'm in all the way down to any subdirectory that I'm in and look for files with specific attributes. This example right here is running find on slash, so from the very top of the file system, for a file with the attribute that its case-insensitive name matches the pattern FOO star. We'll get into what that star means in just a second, but it's called a wildcard. So basically, any file from slash down that has a case-insensitive name starting with FOO. You'll notice I quoted with single quotes. We'll get into that in a minute as well. Quoting is awful important in the shell. Like I mentioned earlier, you can take the output of one command and put it into the input of another command. So if we run command 1, we type the pipe character, which on my keyboard is a capital backslash, not necessarily the case on yours. Put that into another command. Then we have the open, or that's a greater than, right? This is what's called a redirector. So this is process piping, and this is a redirector. So basically, instead of spitting out the output of this command into your terminal, It's redirecting that output into a file named redirected output. We run a command foo, and we put 2 greater than. That's going to redirect the standard error file handle to this file. If we echoed foo, you'll notice I did double quotes here. Pipe that through WC, which stands for word count. Pass the switch to WC to tell it not to count words, but to count characters. This command would tell you that there are 3 characters in the word foo. Right? And if we did this command, cat, which stands for concatenate, basically take all of these files that you pass me and spit them all out at once. But we do that on a non-existent file, what do you think is going to happen?
Error.
It's going to, what do you think the error would be?
File don't exist.
File doesn't exist, right? Most often it says file not found. And what's going to happen is it's going to print that out to the error stream. But if I'm redirecting the error stream to this special file called dev null. Anyone want to venture a guess as to what dev null is?
Bitbucket.
It's colloquially known as the bit bucket. It's a special file on the file system that just throws away whatever you give it. So if we redirect the error output to dev null, what's the output of this command going to be?
Nothing.
Nothing. Why is that?
It got dumped.
It got dumped to the trash can, right? This is like putting your printer right in front of your shredder. Right? The paper comes out and just drops right in the shredder. This is what it looks like graphically. Oh, back. So you can use these strings to talk about standard output, standard error, and standard in. The kernel sees them as integers. So the kernel sees standard in is 0, standard out is 1 or blank, and standard error is 2. So we could do cat foo redirect with a 1 to output 2 to error. We don't have to supply the 1, though. The 1 is assumed. Right? Now, I didn't put this on my previous slide, but you can do the following. Cat some file with a less than, and what this does is changes standard in. So instead of standard in coming from the previous command, it comes from the contents of that file. Right? So you can change where these things point to and from. If you want both of these things to go in the same place, it looks like this. An ampersand greater than will put both standard error and standard out into the same file. Globbing. So very often you're going to want to run as an argument to a command a whole bunch of different files all at once. I want to get the last line from every log file. I can do tail, which is a command, minus n1 star.log. Star matches 0 or more characters. Question mark matches 0 or 1 character. And what does this do you think? Anything dot txt or anything dot log. Kind of cool. There's a lot more to globbing than just this, but this is what you're going to use 95% of the time. Right? Variables. Occasionally you need to set a variable. You do so by saying a variable equals and then quote it. always quote it. When in doubt, quote it. There are occasions when you don't want to quote it, but unless you know exactly what that is, always quote your variables, right? Now, my var is set to high there. Echo my var. Now, I'm using this syntax here just to get you in the proper frame of mind of using it. You don't need to use the curlies. You could very easily do echo dollar foo without the curlies. The reason to do this is that it gets you in the good habit of using the other syntax for specifying a variable, which lets you do things such as if I did it like this, you see the difference there? The first example is give me the value of the foo variable with bar on the end. The second variable, the second thing is giving me what? Variable foo bar, right? So quoting like this is fairly important. Now, when you quote, double quotes will dereference variables, single quotes will not. See the difference there? So echo $myvar in double quotes gets us hi there. Single quotes $myvar gets us the literal representation there. Right? All right, so any questions or comments up to this point? How are we doing on time?
37 minutes in.
37 minutes in? All right, so we got about 10 minutes left. Let's do a couple of examples here. Actually, let's pull up my actual VM. So here I have a Linux command. Oh my goodness, have I forgotten her password? I think I have. All right, so we'll use this one. All right, so this is what it would look like if you had Linux installed on your laptop, right? It's going to pop up. I had primed the other user, but I forgot her password. So you get this interface here. This is called GNOME, which is basically a windowed operating system. I'm going to open up the terminal here. And make it a little bit bigger, maybe. All right, and now I'm going to show you some basic commands, right? So you're given a variable, you're given a terminal. It lets you, make directories. I'm currently in /home/vagrant/examples because I made that directory with mkdir, and then I typed cd examples. Right? So here's a way. What do you think that's going to do? I'm going to go up a level, right? What is that going to do?
Keeps you right where you are.
Does it? That's a bit of a trick question. You end up right where you are, but it doesn't keep you where you are. Okay, a little bit of a trick question there. If I cd into a directory, I've gone into a directory, I type cd ... and I bounce back to the parent directory. If I type cd ... I do this. What's the difference about not doing anything? I was previously right here, and I am currently right here. Here's one that's, so let's try this again. Let's go to user share doc, which is a folder that's full of documentation, right? If I do cd space dash, that takes me to wherever I was previously, not the parent directory, but takes me back to wherever I was previously, right? Here's some other things. This is a very useful command if you have multiple places to go and then you want to come back the same way. Instead of typing cd, you type push d. And that puts me into user share doc and puts it on a stack of where I was previously. That tilde there means my home directory. Now if I do push d var log, I'm in /var/log. Then I can do push d user share, push d etc. So I'm just jumping around the file system. And now I want to go back the exact same path that I came from. I typed popd. That puts me in /user/share. That puts me back in var log. That puts me back in user share doc. And that puts me back in my home directory. And now my directory stack is empty. There's nowhere else. I've unraveled the entire string that I left for myself. Right? I've sucked it all the way back into the real. Useful. All right, now let's look at some important things as far as file permissions. I'm going to create a bunch of files here. So I just created a bunch of variables. The ls command lists them. ls-l shows us a bunch more information. I really should have written a slide up for this. I'm sorry I haven't, but I've got a document that will show you permissions that I'll link to in the after action report. ls-l gives us a bunch of information. The first character here is the type of file. Let me make it just a so what I did there is I just created a bunch of different types of files, right? Bar here is a symlink, which is not a true file. It's a file that points at another file. Like, I live here. Dash means it's just a regular file, right, with some sort of contents. P is a socket, or excuse me, no, this is a pipe. My bad, pipe. This is what's called a first in, first out pipe. So if I write something to it, then that gets out the other side. So I can write cross-process programs by creating something on the file system instead of actually having to do like a programming RPC method. I can just use the file system methods. D stands for directory. And then you've got a permissions string. Read, write, and execute. This is for the user that owns the file. These three are for the group that owns the file. And these three are for everybody else. So this is the link count, I think. So how many things reference to it? I don't really use it that often, so I don't remember. or the size, one of the two, I don't remember. This is the user that owns the file, this is the group that owns the file. This actually might be the size here. And then you've got the date that was created, the name. So, what can I, as the user vagrant, do to the directory foo? I can read. What does that mean in the what's the word I'm looking for? In the criteria of a directory, in the parlance of a directory. So if I have read permissions for a directory, I can see what is in it, right? What if I have write permissions for a directory? What does that mean? I can put files into it, right? What does execute on a directory mean, do you think? You can go into it, right? So if we think of a directory like a room, the door is the access, right? If I have read access, I can look through the window of the door and see what's inside the room. If I have write access, I can throw something magically into the room and it'll be allowed to go into the room. If I have execute access, I can actually open the door and go in. Now let's assume for a second that I only have execute access. What can I do to that directory? If I only have execute on a directory, what can I do?
You can go inside but you're blindfolded.
I can go inside, but I'm blindfolded, right? And I can't leave anything there, right? Why would that be useful? That's kind of a contrived example, but it just shows you what permissions are, right?
Well, I have an example. So when I was in school, the TAs would write these test scripts that you can test your application against, but they didn't want you to see what the script was actually, like what was inside the script. And so the folder had only X permissions, so you could go inside of it, and then you could execute the script, but not be able to see what was supporting it and
what other files were there, etc.
And you can't read the file, all you can do is execute it.
If you can execute it, it can do what it's supposed to, but you can't read what's on the contents. There you go. So there's a good example, right? Not entirely contrived then, right? So that's permissions. Like I said, I'll link to, there's a flow chart that I created about 10 years ago, 15 years ago, that have all the Unix permissions. So it'll give you a better idea of what the permissions are, right? Let's see, what else do we have here? Oh yeah, we need to talk about editing files. So editing files, I'm going to give you three editors. And I'm going to tell you that you need to learn at least one of them. And that is VI. Okay? Now, you laugh at me. It is a little difficult to learn VI. I'm not going to sugarcoat it. But if you are on a Unix-like system, you will have VI. You might not necessarily have the editor that you know how to use. Learn how to open a file, write a file, and exit a file, exit the editor in VI at a minimum, right? Pico and Nano are kind of like a text-based notepad. They're pretty straightforward. I'll show you all three here in just a second. I like to joke that the learning curves of each of them go like this. That's just my humor, right? Like the learning curve for Nano and Pico is that there's not one. The learning curve for VI is you're going to struggle, you're going to struggle, you're going to struggle, and then you're going to have that aha moment, and then VI is going to become second nature. My fingers know the VI commands, my brain doesn't, right? Let's show you what that looks like. All right, this is Nano. You just start typing. It ends up in the buffer. And then $X, that means Control X, will exit. Control O writes it out. So we do Control O, that writes, we hit enter. Control X, we've exited. Right? All right, now let's look at VI. All right, VI has 3 modes. Insert mode, actually, 3 basic modes. Normal, insert, and EX. In normal mode, when you bash on the keyboard, you're giving VI commands, which basically means move here, move there, delete, replace. Some of the commands in normal mode put you into insert mode. Insert mode is what you type is what you get. And then EX mode is where you actually get to exit. So let's look at this. What mode are we in here? Normal mode. So if I type an L, that moves me 1 character to the right. JJJ moves me down. Come on, fingers. Oh, here. There we go. H. See, my fingers know how to do it. My brain doesn't. So H moves us to the left. J moves us down. K moves us up. Now, there is an esoteric reason for this. The arrow keys on the PDP-7 were on the HJKL characters. Right? So that's the reason that it does that. To go into insert mode, you hit I. And then you start typing. To go back to normal mode, you hit escape. And then to get into EX mode, you hit colon. And it drops you down to the bottom of the screen, at which time you type W, which stands for right. Hit enter, and that puts me back into normal mode. Colon, Q, quit, and I've exited the file. That is all you need to know about VI. Right? Now Emacs. Oh, I don't have Emacs installed. So I'm going to install it real quick. But while that's installing, if I can get
And it has a lot of dependencies.
it does. Trying to get to my other window here. So while that's installing, I want to talk about what's next. We're just about out of time here. Learning Powertools. Run screen or tmux. What this allows you to do is start a terminal, disconnect from it, and connect to it again from somewhere else. Instead of starting a terminal like on a remote machine and having someone, take a backhoe to your DSL, and then whatever was on that terminal is now gone. So what this does is you connect into tmux, it runs. If the backhoe takes you out, you go to a McDonald's Wi-Fi and you connect back to whatever was running here. Really cool tool. Learn shell scripting. Learn bash shell scripting, and you'll get more efficient. My brother, who also works at Bluehost, he works in the customer support center. He had to do a bunch of file cleanups. We got a whole bunch of accounts that got bad stuff on them. And he was logging into each one, doing the deletion, logging out, logging into the next one, doing the deletion, logging out, all manually. I showed him how to write a shell script, and he did the last 3/4 of them in 3 seconds. The others took him a couple hours. Play with your text tools. Learn regular expressions. That is way past the scope of a Linux 101, right? Regular expressions are how you pattern match on text, right? Like I want a J followed by a K or an L followed by 6 or more digits. You can do that in a regular expression. Sed is turning regular expressions into a text processor. I want you to replace every example.com with foo.com in this file. Awk, kind of the same thing. grep is globally search for a regular expression and print it. grep. There's a lot more to grep than just that, but basically, I want all the lines that came from this IP address in this log file. I would use grep to do that. And then I would take that output and I would pipe it through cut to get just the field that I wanted. So cut lets me separate a line into chunks. Paste, kind of the opposite. I have two files, one with first names, one with last names, and I want a file that has first name, last name. I use the paste command. Sort, well, I want that file to now be in alphabetical order. Right? Use these tools. The next thing is, how do you get help? Now, this is probably the hardest part. You just have to play with it. It's like learning a language. If you don't immerse yourself in it, you'll never learn it. Right? You're going to get this somewhat unhelpful or somewhat hostile response sometimes. It's not as bad as it used to be, but you're going to read the freaking manual. And I'm using the freaking because we're here in Utah County. But RTFM, read the freaking manual. Yes, you need to learn how to find the answer yourself. Or just effing Google it, or let me Google that for you, right, is another one. Search Google, right? Do your research before you get like how do I install live CDs is a good one. Like how do I download a live distro, right? How do I download a live distro? How do I run a live distro? I'll walk you through it if we had one-on-one time, but we just don't have the time in a 101 class to do that, right? Look in user shared doc. There's a whole bunch of stuff in there, like example configs. Mailing lists. Who here knows about this exact meeting because of the plug mailing list? Right? Jump on the plug mailing list, full of really cool people who are really quite useful. As far as user group mailing lists go, plug is probably one of the best. IRC. There's Pound Utah on Freenode. We all hang out there, Doran and I and a whole bunch of other folks here. And we're more than willing to help. Like, hey, I heard someone talking about blah, blah, blah. Oh yeah, it's over here. It's pretty much open source in Utah is Pound Utah on Freenode. Really great resource. You're in one of the best places now to learn about Linux, a users group. There's been talk about doing an install fest or some sort of workshop. I'm sure we'll try to figure something out like that in the spring. So keep an eye out. Right? We'll do an install fest or a workshop, or we'll do a meeting here. We'll just set the tables up and come and get help with your problem. Right? Play. Scratch your own itch. What do I mean by scratch your own itch? I've found that I don't learn something unless I have a reason to have learned it. If you give me a stack of flashcards, I won't learn a language. But you give me Don Quixote, and I will learn ancient Spanish to read the book, right? Scratch your own itch. Install a WordPress site. Plug for my employer, Bluehost. Dirt cheap WordPress installs. You can get in, you can play, and you can do Linux. Play with it. VirtualBox is a really cool tool. It lets you run Linux in a virtual machine. So you don't have to install it on your hard drive. Just play. And sadly, we still kind of have to say this. Grow a little bit of a thicker skin. You're going to, so here's the thing. The people who were originally in the open source movement got there with their own blood, sweat, and tears. Right? And with their own initiative for the most part. So don't feel like it's a personal attack if they come off as brusque or what's the word I'm looking for, rough or annoyed or whatever. Because, you know, they've had 15, 20 years of people saying, you know, how do you get out of Vim again? Right? Which, you know, some people can answer that 3 million times and be fine. Some people snap and say like, oh, the professor, blah, 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 blah. And there's a term for that. It's called the Eternal September. At one point, AOL put all of their people into news groups. And basically a bunch of college freshmen ended up invading the internet that was just barely getting started and started asking what were perceived to be stupid questions. And learn how to ask a question. I guess that's what I'm trying to say, right? Instead of saying, someone give me the answer, say, I'm having a problem with X and I've done Y and Z, what should I try next? You see the difference? Instead of, you know, I don't need to belabor the point, but play. Get in there and enjoy it. Right? Find something to do with it. The Raspberry Pi is a great place to play. Right? It's a $35 computer with an electronics kit built in. Right? 35 bucks. You connect LEDs and buttons to these little pegs, and then you write Python or shell scripts to blink lights. And I've actually got an internet-enabled doorbell I built with a Raspberry Pi. It texts me when someone rings my doorbell.
Oh.
That's fun. Get in there and play. Enjoy. Linux is not as as difficult as it has been in the past. It's really a great, powerful tool, and it really will open your possibilities up. Do we have any other questions or comments? Concerns? Bad jokes? No? Well, I just want to say thank you. It's been a pleasure. My name is Derek again, derek@goosebach.com. I'll email converse with you. I'm at Goosebach on Twitter. This will shortly be up on presentation.goosebach.com, which it's been in 4 or 5 different implementations, this actual presentation. I'll send a link to the slides, which are on a Google Drive, and I'll post all this to the plug list. Doran's got video, hopefully with some good sound. We won't know for sure until we get it rendered, but thank you very much.